1 into 10 power minus 29. No, it's a standard value. Mass of the electron 9 into 10 power minus 31. Particle is moving and magnetic field is perpendicular to velocity. This is the correct statement. The balancing length of the primary circuit gives the potential of the secondary circuit. In my previous sessions, if you have followed, I have written an expression for current in terms of EMF and resistance. Going to the next question. A voltmeter reads 4 volts when connected to a parallel plate capacitor with air as the dielectric. In the problem, voltmeter reads 4 volts when it is connected to parallel plate capacitor with air as the dielectric. Initially, which is the dielectric medium? Air. ಎರಡು ಪ್ಲೇಟ್ಗಳ ಮಧ್ಯೆ air medium ಇರುತ್ತೆ. When a dielectric slab is introduced between the plates for the same configuration, the voltmeter reads 2 volts. ಅಂದ್ರೆ ಸೆಕೆಂಡ್ ಕೇಸಲ್ಲಿ ಒಂದು ಮೆಟೀರಿಯಲ್ ಮೀಡಿಯಂ ಇರ್ತಿದ್ವಿ. ಆ ಎರಡು ಪ್ಲೇಟ್ಗಳ ಮಧ್ಯೆ ಒಂದು ಮೆಟೀರಿಯಲ್ ಮೀಡಿಯಂ ಅನ್ನು ಇಟ್ಟಾಗ ವೋಲ್ಟ್ ಮೀಟರ್ ರೀಡ್ಸ್ 2 volts. What is the dielectric constant of the material? So we have already studied dielectric constant is the ratio of something with air as the medium to something with the material as the medium. So here epsilon is voltage with air as the medium to voltage with slab as the medium. When air is the medium, the voltmeter is reading 4 volts. With slab, it is 2 volts. So, the dielectric constant is 4/2, which is equal to 2. Next. Spherical conductor of radius 2 centimeter radius is uniformly charged with 3 nanocoulomb charges. Electric field at a distance 3 centimeter from the center of the sphere. So all of us know electric field is 1/4 pi epsilon naught q by r square. Careful ಆಗಿರಬೇಕು. Potential ಅಂದ್ರೆ q by r, field ಅಂದ್ರೆ q by r square. So this is 9 into 10 power 9. Charge is 3 nanocoulomb. Distance is 3 centimeter. So r square. So this 9 gets cancelled. 3 into 10 power 4 volt per meter should be the answer. This is 10 power 4 volt per meter. A carbon resistor has color code green, black, violet, gold. Value of the resistor BB Roy, you get the third option. Now, the next one. 2 resistors of resistances 2 ohms and 6 ohms are connected in parallel. So, ಎರಡು ರೆಸಿಸ್ಟರ್ಗಳನ್ನ ಪ್ಯಾರಲಲ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ, 2 ohms and 6 ohms. This combination is then connected to a battery of EMF 2 volts and internal resistance 0.5 ohms. What is the current flowing through the battery? My dear students, in my previous sessions, if you have followed, I have written an expression for current in terms of EMF and resistance. So, current is EMF divided by R plus small r. Now the two resistors are connected in parallel. So what is the effective resistance? 2 into 6 divided by 2 plus 6, 12 by 8. So which is, yes, 3 by 2. So if you substitute here, EMF is 2. So 3 by 2 plus 0.5, which is 2. 3 by 2 is 1.5 plus 0.5 is 2. So the answer is 1 ampere. So 1 ampere current is flowing through the battery. The equivalent resistance of two resistors connected in series is 6 ohms. When two resistors are connected in series, equivalent resistance is 6 ohms, and in parallel is 4 by 3 ohms. What is the value of the resistances? By inspection method only you can get. If you check all the 4 options, series aliddaga equivalent resistance 6 ohms ಬೇಕು. 4 plus 6 10 ಬರೋದಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ. 8 plus 1 9 no. 6 plus 2 no. If you observe here, so the options 4 ohms and 2 ohms, 4 plus 2 is 6. So naturally, for these two values, you get 6 ohms as answers when connected in series. So this is the correct option. In a potentiometer experiment, ಮಾಡಿದಿರಲ್ವಾ, comparison of EMF of two cells. A cell of EMF 1.25 volts gives a balancing length of 30 centimeter. So E1 is 1.25 volts, balancing length 30 centimeter. If that cell is replaced by another cell, balancing length is found to be 40 centimeter. What is the EMF? So in the experiment, we wrote the expression E1 by E2 is L1 by L2. The balancing length of the primary circuit gives the potential of the secondary circuit. E1 by E2 equals L1 by L2. Even ಎಷ್ಟು 1.25 by E2 is 0.3 divided by 0.4. So on inspection, it has to be greater or equal to 1.67 volts. A charged particle experiences magnetic force in the presence of the magnetic field. Whenever there is a magnetic field, charged particle experiences a magnetic force. Which of the following statement is correct? The particle is moving and magnetic field is parallel to velocity. No. Particle is stationary and magnetic field is perpendicular. No. Particle is stationary and magnetic field is parallel. Absolutely no. Particle is moving and magnetic field is perpendicular to velocity. This is the correct statement. If a velocity has both perpendicular and parallel components, then naturally the path traced has to be helical. There is perpendicular as well as parallel component. Then it has to be a helical path. This was a question which went to Grace. All the 4 options were wrong. So a Grace marks was awarded. Gyromagnetic ratio. ನೀವು ಅದ್ರ ಮೇಲೆಲ್ಲ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಕ್ ಹೋಗ್ಬೇಡಿ. What is the mass of the electron? So all of us know mass of the electron is 9 into 10 power minus 31 kgs. So I can now go for elimination method. Minus 31 irlebeku. 1 into 10 power minus 29. No. It's a standard value. Mass of the electron. 9 into 10 power minus 31. Minus 3. No. Nowhere related. Minus 7. Absolute nonsense. Now if you take 1 divided by 11, it is nearly 0.009. 9 ಸಿಕ್ತಿದೆ. Power shift ಮಾಡಿದ್ರೆ minus 31 ಸಿಕ್ಕುತ್ತೆ. So the 4th option is the answer. The value of shunt resistance required to convert a galvanometer of resistance 100 ohms into an ammeter of range 1 ampere. Smart sari madidini. What is the expression for shunt? S is Ig into G divided by I minus Ig. How much is Ig? Current for full scale deflection 5 into 10 power minus 3. Resistance of the galvanometer is 100 divided by I is 1 minus Ig, again 5 into 10 power minus 3. So simplify madi. Minus 3 plus 2 is minus 1. So this is 0.5. 1 minus 0.005. So if you observe, the option has to be the first one. A circular coil of radius 10 centimeter, 100 turns, carries a current of 1 ampere. Magnetic moment of the coil. So what is the expression for magnetic moment? M equals I N A or N I A. So N, there are 100 turns. I 1 ampere. So this is pi r square. Or this becomes 10 power 2 into pi is 3.14 into radius is 10 centimeter, 10 into 10 power minus 2 whole square, 10 power 2, 3.14, 10 square into 10 power minus 4. Idನ್ನು simplify ಮಾಡ್ತಿದ್ದೀನಿ. Cancel ಆಯಿತು. So 3.142 will be the answer. Susceptibility of a magnetic material is 400. Naturally, it has to be a ferromagnetic material. Susceptibility is 400. A solenoid of inductance 2 henries carries a current of 1 ampere. What is the magnetic energy? Expression for energy stored in a solenoid. U equals half L I square. So how much is the inductance? Or 2. I square is 1. So 1 joule is the answer. Nodi, just expressions. Anywhere, any complications with the simplification? Absolutely no. Multimeter reads a voltage of certain source as 100 volts. So this is the VRMS value. What is the peak value? So how do you relate RMS and peak value? VRMS is V0 by root 2. Or V0 is VRMS into root 2. So 100 into 1.41. So third option is the answer. Here the same question is repeated. D is the answer. 2 times in the previous sessions. Now again here 20 amps. This is again done before. Now the average power dissipated in an AC circuit is 2 watts. Average power. ಎಷ್ಟು power dissipate ಆಗ್ತಿದೆ? 2 watts. If the current flowing through the circuit is 2 ampere and impedance is 1 ohm, power factor of the circuit has to be calculated. So we know average power is VI cos phi. So power factor ille bantu siktu nanige. By expression, power dissipated is VI into cos phi. Cos phi is the power factor. But impedance has to be put here. See, we know V equals I into R, Ohm's law. But since it is AC circuit, resistance is called impedance Z. So V is I into Z. So this is I square Z cos phi. That is the power. Or cos phi is P divided by I square Z. How much is the power dissipated? 2. What is the current flowing? 2 amperes. So 4 into Z. 2 by 4. 0.5 is the answer. Plane electromagnetic wave. I want magnetic field vector. Velocity selector condition. E by B. So B is nothing but E by C. So E ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? So electric field is 6. 3 into 10 power 8. So the answer is 2 into 10 power minus 8 Tesla. Going to the last question. Now there are two capacitors of 10 picofarad and 20 picofarad connected to 200 and 100 volt sources respectively. Two capacitors of this capacitance connected to these two sources. If they are connected by a wire, what is the common potential attained by the capacitors? Now, by definition of capacitance, C is Q by V, or V is Q by C. Therefore, common potential is charges Q into C. Alva Q beko C into V. So I can write this as C1 V1 plus C2 V2 divided by C. C1 plus C2. The numerator here is giving me the charge by this expression Q, C into V. Or V equals, how much is C1? 10 into V1, 200 plus C2, 20 into 100 divided by C1 plus C2, 10 plus 20. So this is 2000 plus 2000 by 30, which is 4000 by 30. So this nearly 133.3. So the common potential is 133.3 volt. So very clearly you see simple mathematical simplifications adjoined with proper concepts. Any question can be solved very easily. Thank you.